thank you for joining us at the Microsoft Fabric UK User Group. I'm your host, Leon Gordon, and I'm here with my co-host, Pragati Jain. Pragati, how are you today?
Hey, Leon, I'm good. How are you?
Yes, fantastic. Thank you. As we were saying behind the scenes, very busy, which is great. And I know you are too.
Yeah, of course. I mean, it's busy time, I guess. So much going on. But yeah,
Yes.
as you say, it's good to be busy, right? So all
Oh,
good.
absolutely. Looking forward to going into the festive breaks. I probably shouldn't speak too much about it at the moment because it's still a bit of a way off, but it's going to creep up on us very quickly. With us saying that, Pragati, as well, I know you wanted to mention something at the beginning of the
Yes.
webinar, so please feel free to jump in.
Yeah, so I think I would just like an opportunity to just talk about a little bit about Data Weekender. So Data Weekender is happening next week on Saturday, 4th November. And it's a virtual conference happening from morning 8 to evening 5 in the British summertime. So if any of you guys are interested about, learning about Fabric, Power BI, or anything about data platform, then please do come and join us. It's a virtual conference. So, you just need to hit register and you can just attend it from your own space. So I'll just pop in the links where you can actually find our agenda along with that, the registration link as well. So please go ahead and register for the event. It's a free event, so you don't have to pay anything. Just go and register and just take some benefit out of the event. So thank you so much. That's it.
Thanks, Pragati. I mean, if everybody can let us know where they're joining us from as well, that would be fantastic. And Pragati, one thing I can say about our community is two things. They love things being free, which we all do, myself included. And we love learning about Power BI and Fabric. So I'm sure we're going to get a plethora of signups from the community.
Definitely. I mean, we have got amazing speakers lined up, and even the speaker who's today our guest, he's going to be again one of the speaker for the Data Weekender. So not just Fabric and Power BI guys, SQL Server, pipelines, whatever within the data platform, we have got too much there coming. So please come and join the meetup, basically.
Excellent. Fantastic, Pragati. And with that being said, I think it's best that I introduce our speaker for today. So it's the one and only Steve Campbell, who's going to be joining us to talk about demystifying Microsoft Fabric and OneLake. So Steve, let's bring you onto the screen. How are you doing today?
Hi, I'm doing really well, thank you. How are you both?
Yes, fantastic. Thank you. Really looking forward to this session. I think even the title of the session answers a lot of questions. The fact there's been a lot of conversation around what is OneLake. People are still asking what is Fabric. So turning that into a session to demystify that is going to be absolutely amazing. So I think Pragati, it's best if we pass over to Steve to allow him to jump straight in.
Exactly. Good luck, Steve.
Excellent.
Thank you. So yeah, before we dive in, a little about me if you're not familiar. So my name's Steve Campbell. I do mostly Power BI. I do a lot of Power BI training and I'm in the consulting space. So I own my firm Sunny BI. Again, we do lots of training and reporting from Microsoft Data Analytics, do a lot of things such as rolling out big projects, rolling out BI platforms, that sort of stuff. Love being in the training space, and obviously with Fabric, all of the exciting stuff that's coming out on Fabric, I wanted to do this session around demystifying it and still actually understanding what it is and what it is under the covers. This website here, Sunny BI Training, I'll bring it up again at the end. If you go to this website, I have a lot of little videos which are easily viewed on your phone that will explain a lot of the concepts. So pretty much all the concepts I'm going through today. If you want to remember one and you just want to see a specific concept, go to that website as well and you'll be able to see it there. So with that, the boring stuff out the way, let's get on to the topic. So demystifying Microsoft Fabric. This is going to be no code. In fact, there's not going to be demos. Funny enough, we're not actually going to go and look at Microsoft Fabric. We're understanding the introduction and really what's happening underneath the covers. So we want to explain really what is Fabric, focusing on OneLake and also focusing on how Power BI fits within Fabric. A lot of this is going to be setting this up before we get into Fabric. So the first half, maybe even a bit more than half, is going to be talking through some underlying concepts such as data lake, such as Parquet and Delta files. So if you're familiar with Fabric at all, it all revolves around this thing called Delta files in a data lake. So in order to really understand Fabric, we have to go back, see what these are, and understand how everything works underneath the covers. As I said, it's not going to be demos on the Fabric. We're not just going to go jump in and look at some code that we don't understand. We're going to have a very high, well, it's going to be in-depth, but it's going to be easy to understand, hopefully. Go through the concepts. Please do ask questions along the way. The advantage of everyone here watching live is that you get to ask questions and I can answer them in real time. So with that, let's talk about our first concept. We might start off, so you might know a bit of this at the beginning and we'll ramp up, but some of these concepts we just need to build on at the start. So a data lakehouse. What is a data lakehouse? Firstly, let's introduce what a data warehouse is, because data lakehouses are, I would say, a newer way to structure data and to hold data. But previously we've had data warehouses. So these are things like our SQL databases, SQL warehouses. And we call a data warehouse structured. So what we mean by structured is we love data like this, right? And this is how we like it in Power BI. We like things in tables. So we have rows and we have columns. Data warehouses have really strict rules, right? So I can't put a text value into a date column, all of this kind of stuff. So it's very structured and it's very robust. This is good because it keeps data quality. When we get to reporting, everything's in the correct format, and this is how we want to look at the data. But what about other formats? And this has become more and more important with the kind of explosion of computing power, how cheap actually data storage is now compared to a decade or two ago. So what about pictures? Now you see loads of pictures, machine learning right now, right? And I think we can all say even in the last year, that's loads of new kind of machine learning things are coming up. So obviously this needs pictures, identifying, what's a cat in a picture, that kind of stuff. Audio as well. One of the most common is we'll see most videos, and probably if you're watching this on YouTube on replay, it's going to have subtitles, and that's probably automatically translated from the audio. So all of that comes from machine learning. Streaming data, and this is my symbol for streaming data. That's coming in really quickly, kind of unstructured. And then just generally unstructured data. So things like emails. If we try and have formats that store emails so that we can do machine learning, we can't really put emails in a table because we don't know what's going to be the format of the email. So all of that obviously has to live somewhere else. And that's what we say, we're going to put this into a data lake. So really a data lake is pretty much just a big storage. And it stores, this structured, semi-structured, plus this unstructured data. And that unstructured data could be those things like the emails. It could also be these images and the audio. It's really good as well for data science, because data scientists don't always want things in tables. If you're doing algorithms that detect things in images, obviously tables won't work. You can have big amounts of data. Because now data lakes and storage is getting very, very cheap, it's very easy to have all this data and just dump it in a big data lake. It's very quick as well to load data into a data lake, because unlike a database, we don't have to worry about strict rules of which tables and how to format the data. So before we speak about a data lakehouse, we want to speak about a concept called ACID. And I've put this ACID in databases. So this is a very important concept that we'll mention a few times today. So what is this concept of ACID in databases? So we've seen a database, or we've seen a data lake. In databases, however, you have something called ACID. So this is with our structured data. Imagine I have two tables, right? Here's my account on the left and my stores account on the right. And I want to buy something. So what I'm going to do is I'm going to make a transaction from my account into the stores account. However, there's two things that need to happen. Firstly, they need to take the money out of my account. Secondly, they need to add the money into the stores account. So if you can see, the amount of money left in my account is pretty much just the sum of the amount, right? So at first I had $1,000 or pounds, wherever we're from. I've spent 100 on something else, and then I spent 200. So now I have 700 left, and then the store got that 200 and we put it into their account. Very simple. But what happens if we do this? Let's say we're going to run these two transactions. They take the money out of my account, but then something goes wrong, right? The whole server goes down. There's an unexpected outage. Everything restarts, and we completely lose all the processes that was running. Well, now we're a bit stuck because I've taken the money out of my account. The system's reset and it didn't know where it was. And so it's not going to know that this was for this transaction. It's not going to know that it hasn't added it to the stores account because we had something that went wrong halfway through the process. So I'm going to be annoyed because I've lost the money. The store doesn't get the money and everyone's going to be pretty annoyed. So this concept of ACID is, it stands for these four things. And it basically says, how do we protect against this sort of thing happening? So the first is automaticity. And automaticity states that all statements take place or the transaction doesn't happen. So whenever we do this, when we say we're taking money out of my account and adding money into the other account, there is logic and there is rules around database because they're nice and structured. We can say that if something happens during the middle, we need a system, a process where we say we'll roll everything back so the transaction can't be aborted halfway through. We can't have half the money taken out, for example. The next is consistency. So all database rules must be observed, such as constraints. So, for example, I can't add the wrong type of data into the wrong column. So this is really, really important, and this makes it very, very structured, right? So, if a date column is a date column, I know there's only ever going to be dates in that column. Same with, numbers. This obviously is really, really important, and when we go to build reports, it's even more important. The third is isolation. This says no other processes can happen at the same time. Let's go back to example, and let's imagine this time that we're buying something for a bit more. And it can happen either way around. So, it could take the money out of my account, then add it, or theoretically, if this is happening, it could add it into the stores and take it out. It's going to try and do this at the same time, but obviously it can't do this to the exact millisecond. So let's say it's added it to the stores account. Then it's saying, now I'm going to take the money out of my account. However, almost simultaneously, before that's happened, I've gone and spent $800 elsewhere. So it credited the stores account, but before it could take the money out of my account, almost instantaneously, I've spent money as well. Another process has happened. So now, if you look, I've spent $900. I only have $100 left in my account. So it's already added the money to the store, but it doesn't have enough money to take out my account. So obviously we need rules to stop this from happening as well. So isolation means, right, no other processes. We need to be isolated from other transactions happening. So these transactions, right, a transaction is really a sequence of events. This transaction is these two statements. Take money out my account, add it to the stores. So no others can affect it. So it has to happen in isolation. Finally, durability. And this just really says, right, once complete, we have to make these changes permanent. So if the system does restart, these changes will be permanent, right? They're saved to disk. So that is ACID. So ACID is a concept that we have in databases, and it's very important. And we said databases are structured, and because they're so structured, we can have these rules. They're easy to enforce. So what's a data lake house? Well, a data lake, as we said, it's good for data science. We get loads of data, it's quick, and we have structured and unstructured data. Data warehouses are really good for business intelligence because we can do this ACID stuff, we can do strict data validation. Now everything's really strict, and we can make sure everything looks really, really good. So we have these two opposite sides, and people have said, well, data lakes are really good, data warehouses are really good. So what if we just kind of merge these together and said, let's make a data lakehouse? And that's essentially what they've tried to do. We're saying, well, why don't we take all the rules that we're doing on the data warehouse and add them to the data lake? So how does that work? So data lakehouses are really just a form of architecture. Let's imagine we have this data here, and this is a table. This is the raw data. We can see, maybe here on this row, that the sales ID doesn't conform, right? There's obviously an error. We have missing data over here, and this date is in the wrong format. So this data is wrong, right? This doesn't really pass our tests. What we can then do is maybe we can just clean this data. We might just, for simplicity's sake, let's just delete all the bad data out of this table. And then we might say, the next step is actually, okay, we don't want everything in one big table. We're going to start making some data tables. We're going to maybe do some aggregations, get this ready for business intelligence. And these are really 3 steps that make up a lakehouse. Now, lakehouses are a bit more, but essentially it comes down to a lot of the architecture. And you'll often hear this thing called medallion architecture, where we say we have this bronze layer. This is the raw data. So what we do is we copy all the data into our data lake. We have a copy where it's raw. We then make another copy, and this is where we validate it and deduplicate it. Right, so that's where we deleted the rows which were wrong, we fixed the errors. And finally, we might have this gold layer. This is now refined and aggregated, so it's ready for business intelligence. Maybe we do some grouping, maybe we do some dimension and fact tables, that kind of stuff. So this is what really a lakehouse is. It's kind of this structure and architecture that we put around data in our data lake. And we make these copies so that we can always look back and make sure everything's correct. Now, this is a very common pattern. It's called bronze, silver, gold. You can have lots of names for it. You can name it different things. You might hear raw, curated, this kind of stuff. Doesn't really matter, but just having this sort of architecture where you go through stages, get the data ready in stages, and that's the main key idea. So that is really what a lakehouse is. It's essentially just a data lake with some architecture around it. So let's now talk about one of the most important concepts in Microsoft Fabric and in Microsoft OneLake, and that is Delta. So Delta is a way that we can store data. And to dive in first, let's have a little look at column store. Now, I realize I'm throwing terms and going through quick again. These will all be recapped. You can come back, watch this video and repeat. Visit Sunny BI training, and you can also see a lot of this, these concepts. So column store. Let's imagine again, we have this table. 3 columns here. It's called name, sales, and cost, right? Just very simple, we've got 4 rows. Now, we could save this as a lot of different formats. A really popular format is CSV, comma separated values. And if you open a CSV, you'll kind of see it stored like this, where this is the first row, this is the second row, right? This is the third, and this is the fourth. Because internally, you know, when we compress things and files are stored internally, it doesn't really have this concept of tables. We kind of just want to store everything in a straight line and maybe separate the values with a comma. It's how computers store their data internally. So this is what we call a row store, because we've stored each row, we've just put each row after each other. Quite simple, and we can see which row is which. However, often when we do things like business intelligence, I might say, get a list of, you know, the names. You'll see these names are very spread out because we've got rows and rows of data. Now, whenever the data is very spread out, it makes it actually a lot more inefficient for the computer to go and retrieve these values, because just the sparsity of how far these data points are, it's much harder for it to quickly go and get these data. And because we normally, when we do business intelligence, we pretty much do everything in columns. So we might say, if you're making a Power BI report, I might say, let's put a filter for salesperson, right? Or I might say, here's a legend of year. These are all columns. I want to sum the sales. That's another column. We do everything in this column way. So let's have a look at another way we can store data. So, same table again. Instead of storing it row by row by row, if you hadn't guessed already by the name, columnar store stores it column by column by column. So this is the first column, this is the second column, this is the third column. Now obviously, internally, it needs to know how to decompress this when we want to view it in a table format, and that's what the column store does. So that is column store, and obviously if we wanted to get this column, all the data is very close to each other. It knows that all the column values are right here. So it's a lot easier and a lot quicker and more efficient to actually go get data. Now, aside from all the data being a lot closer to each other, columnar store has a few other advantages on how we can make this much more efficient. Now, what if I said, you know, how can we store this number easier? If I was going to read this number out to you, I probably wouldn't say 3333333333, right? I would probably say 10 3s, 5 5s. And obviously, that's a lot quicker than me saying every number over and over again. So if I'm a computer, maybe I'll just say this. I could say there's 10 of the number 3 in a row, and then 5 of the number 5 in a row. That's a much more efficient way of storing it, right? And making things more efficient with data especially is number one goal. It's how things get really quick, and it's how things storage and gets much cheaper. So we always want to be as efficient as possible. So let's think of this in our columnar store database. Now I'm going to a bit of an extended data set to see how this works. So same thing could happen. The first thing we have to think, right, is columnar store databases store columns next to each other. What we can then do is, because we're not storing it row by row, is we can treat each column differently. And we'll see how that works. So let's look at this name column. Again, same concept. I've got Bill 3 times in a row here. Same with Jane, Sarah and Alice is once. So what if I added some extra data to this? what I'm going to do is I'm going to put a couple of numbers in this cell. I'm going to say, this is Bill. Bill is repeated 3 times, and I start at row number 1. Then I'm going to say, this is Jane. Jane is then repeated 3 times, and I start at row number 4. Same thing as Sarah and Alice, right? Sarah's repeated once, start at row number 7. Alice is repeated once, start at row number 8. So every time I get a new value, I'm going to say how many times it's repeated and what row I'm on when it starts. I'll do the same on this other column. So there's 2, 2, 2, and then the bottom 2 are 1 again. Now I've added this data. Now I've added these numbers. Actually, everything without a number isn't needed to be there. I can still know exactly what it used to look like. So I know all this data when I take away the cells that are numbered, because I know there's going to be 3 Bills and I know there's 3 Janes in a row. So all I need to do is now I can actually remove those values. Because I've added these numbers, I can actually reduce the size of my column. Now, here's the really cool part. Because each column is being stored together, and we're not storing it in rows, I can actually have different lengths of values, so a different amount of rows in my columns. You'll see here my columns are different sizes, but with all the data, I could, as a computer, reassemble the full data set because I know what it looks like. So because of columnar store, it allows us to have different sizes of columns, and we can really reduce, by adding this bit of data, how much memory this column takes. So this is called run length encoding, if you want the official name of it. Now, a couple of things about run length encoding is cardinality refers to the number of unique values in that column. If you can imagine a column which didn't repeat itself, this wouldn't work very well. If a column repeats itself over and over again, it works really well. So that's why in Power BI and any columnar store, so Power BI Vertipack engine also is a columnar store, by the way. But that's why any columnar store, it's very effective when you have unique values, or low amounts of unique values, sorry, when you don't have unique values. Next thing we can do is we can make this even more efficient. So let me have a look at this. These are all the names of my clients. Now I went ahead and I counted all the characters, and characters are just letters. There's 137 letters in this data set. I want to make this as small as possible because obviously the less letters, the less memory this is going to take up. The less memory, the more efficient I am. One thing I could do then is say, well, again, there's some values repeated. So what if I did this? And obviously there will be values repeated because everything is not in a row. So that I've done the run length encoding. There's no repeated in a row, but there's still, I have the same values in the column more than once. What I'm going to do is I'm going to go ahead and make a separate table. It's almost like a dimension table where I just take every unique value and write it down once. I'll give that a key and I'll replace the values in my table with a key. So I can see this is value 1, so I know it's this column. This is also value 1. This is value 2, so I know it's this one. Again, I can still see all the data here. But what I've done is, because I've only written the full length of the text once, now this data set, including my extra table, is only 84 characters. So that's almost half of the characters I've got rid of. So this is a really good way of making it even more efficient. And this is called dictionary encoding. You don't have to worry about the name, but obviously it goes with the concept, the more data in a column, the larger it is to store. So we build this encoding and we assign sort of a value to it. So another way we can do some encoding that happens in columnar stores. So let's have a look at how we can store this in a columnar store format. The first thing we can do is we can do our run length encoding, where we remove the repeated values. So this will be something like this, right? So I've said Bill is repeated 3 times and it starts at row 1. Jane's repeated 3 times and it starts at row 4. And I've done it the same for the client column. Next, for both columns, I'm going to do my little table here. This is now saying I've added this little table and I've done the index. So here, if I wanted to look at the name column, I could say value number 1, which is Bill, is repeated 3 times starting at row 1. Value number 2, which is Jane. Jane is then repeated 3 times starting at row number 4. Finally, I then store this in my columnar format, and I've just highlighted the 2 columns so it's obvious and you can see here. But you can see now how much compression I've made on my original table. So you can see, and obviously I only have, what's this, about 8, 9 rows here. If I have a million rows, this has really amplified the effect and this becomes much, much smaller. So that is columnar store. So how does that go into anything we're talking about? I want to introduce the concept of Parquet. What is Parquet? Parquet is a file format that uses columnar store. So let's go back to our table, our original table here. What we're going to do is we're going to now Parquet does one extra thing. Instead of just storing the whole thing in one big file, it splits it out into little groups of rows. These kind of row groups are then each individually put into columnar store. All the encoding, all that optimization I just talked about would happen. I'm not going to go through it again, but it will optimize this. It will reduce the value, the repeats and all of that. So this is our first column, our second columns, and our third column. Then, now it's split these out into groups. It just saves these as files. So the Parquet format is columnar store files. Then it splits out big bits of data into multiple files. So it just makes it a bit easier to work with instead of having one huge file. So Parquet, it's an open source format, and that is why it's become so popular as well. Because you don't have to pay for it. It's similar with CSV, right? No one owns it and it's open source. It's kind of hybrid column based. So it splits things out into row groups, and then it stores these row groups in columnar store. Great compression available because of the columnar store format. Better OLAP versus OLTP. And what we mean by OLAP is it's better at doing data analytics like the business intelligence where you look at columns. Now, a big disadvantage though, it's not easy to edit. You can't really edit a Parquet file. Instead, what you have to do is you can just add new Parquet files. So it does make managing them a little bit difficult. So that is where Delta comes in. And Delta is a huge part of Fabric and OneLake. So what is Delta? Delta is this Parquet format with a transaction log. That is Delta, which is pretty cool. Obviously, the question is, what is this transaction log? So let's have a look at this table. We have the table name and sales. Parquet, we're going to split these out into 2 separate files. File A, we call it file B. So this is now split into our row groups into our Parquet files. Internally, obviously, this will be stored columnar store format, but just so that we're working through it, we're going to see, I'm just going to keep it in this format. What Parquet does is it says, this is our task 1. So basically task 1 says we split and we have now file A and file B. And it just says so this is delta, this transaction log says we've written down task 1. We wrote down that we added these 2 files A and B into our storage. Let's say we want to change the value Laura, and we've got this wrong. And we want to say, actually, I want to change value of Laura into Alice. And that was a wrong. I'm going to delete Laura and I'm going to add a new value. So as I said, Parquets aren't easy to edit. So what we have to do is we have to regenerate file B, but with the correct data. So I add now file C. So I've done I write some Python. I've said, okay, Delta kind of handles this. And it's added a new Parquet file called file C. So now we have Bill, Jane, and Alice up here. This is the correct value. However, file B, we don't delete file B. And this is the beauty of Delta. What we've done is we write a new task. So in here, this task 2 basically says, okay, what we've done is we're adding file C and we're no longer using file B. So now if I read task 1 and task 2, if I read task 1, it says we've added file A and B. When I read task 2, it says don't use file B, but use file C. So I know I need to use file A and C if I read through all the tasks. That looks like this, and I can see this now builds my correct table because I have Bill, Jane, and Alice, which is the values that I wanted. Then we said, oh no, I'm stupider than I thought. Alice was also wrong. So I'm going to change this, and what I really wanted Sarah. So I've done the same thing, right? We did our Python, it's generated our file, and now we've got file D. We've said, file D is the correct file for this row group, and this is Jane and Sarah. And we don't need to remember all this, right? Delta handles this and tracks all this itself. Now we've written task 3. So task 1 says add file A and B. Task 2 then says don't use file B, use file C instead. Then task 3 says don't use file C, use file D. So if I read through them all, I will be left with saying use file A, don't use file B, don't use file C, use file D. And again, now this builds my new table. So what's the point? This sounds much more complicated than just deleting the file. Well, the beauty of doing this is I can say, what did my database look like at task 2? And all I have to do is read up until task 2. I'll know exactly how the database and the tables look like at that point. And these have date time values associated, right? So as well as saying I've added file A and B, we say the date and the time that we logged this. So what this means is that we can look and we can just say, I want to look at this date and time, and we can look exactly how the data looked at that point in time. That is a really powerful feature, to go back to your database and to know exactly how it looked like. And this is all happening in a data lake. So Delta. It also, by doing this, by having this transaction log, right, we provide this ACID functionality because we know we're writing down each task. If something goes wrong, we can just roll this back at any time. If one of the files gets messed up or something happens, right, we have a history and we're never just adding one thing and then letting it happen. It allows time travel. It's a cool way of saying we can go back and look at the version, basically version control. We can just roll back the database to any point in time. This really helps with debugging, data lineage, so we can really track things, and it's very, very helpful. And then the optimization, and that is largely due to that Parquet being in column store format. That is really well optimized as well. It's just so. when we have, for example, let's have a look at now another cool thing that Delta can do in the transaction log. And this is an extra form of optimization. Let's imagine this simpler. We're going to keep it this simple table to make it easy to understand. We're going to say, let's save this file to Parquet. So what Parquet does, it breaks it into these row groups, and it saves each one of these as its own file in a columnar store format. Now, what's very cool about the transaction log is it doesn't just say, the tasks we've done. It also stores some metadata of each of these Parquet files. So if I said, I want to now query my data, where the sales, select the sales where the sales is greater than 14. So I just want to see all the sales where it's greater than 14. Because these are Parquet files, right? Each one of these we're in a Delta format, and Delta is, each one is a Parquet file with this transaction log. The hardest part of Parquet is it has to, when it's opening a file and looking at the contents, that is going to be the slowest part of this retrieving data, because I have to open a file and scan what's inside it. So what the transaction log does is for each column in your Parquet file, it says the min and the max of that column. So the numbers is the sales column. So I can say my first Parquet file, in the transaction log, I've written down that for the sales column, it's got a range essentially of between 9 and 12. So when I say retrieve all the values where sales is greater than 14, the computer doesn't have to open every single file. It knows that the first file, it won't contain any values greater than 14, because it just has to look at the transaction log and say, this only has sales between 9 and 12. So it only has to open 2 of the files. And that's going to make it a magnitude of quicker, because by far, the hardest thing is opening and looking inside the files. So it only has to do that for 2 of them. So that's a really cool addition to the transaction log. And, it's not just numbers, right? The alphabet is an ordered list. So the names, you can have a min and max. I can say the first one just has bills, saying in Jane and Sarah, so between J and S. And the bottom one, has values between A and S. So it happens on text. And obviously it only has to look in that last file. And in fact, it won't find any names with a D, but it still has to look, because before it looks in the file, it just knows that this has names between A and S. D falls in A and S, right? So it's going to look in this file. There won't actually be any names starting with D. Now, what if though, we don't know what we're going to be querying, so it doesn't know how to store this. So what if it did this? Let's just imagine that we've saved to Parquet, and it saved it into these row groups. It saved into 4 files. And we said, select the sales, where the sales number is equal to 14. Well, currently, it's going to have to open every single one, because 14 falls within the min and max of every single file here. Right? 14 is between 9 and 15, between 8 and 16, and so on. So there must be a way to optimize this, and there is. What we can say is, I can say, I know that I'm going to be querying the sales column, right? The sales column is my most important one. I'm going to be running lots of queries about the sales column. So we can say to Delta, what I want you to do is reformat yourself. And what it does is it reorders and rejigs things. And this may change the amount of Parquet files. That doesn't really matter to us. But now it's saying, okay, I've thought about it, and I think this is the best way to order the data. Essentially, it's ordered it by the sales column and then split the row groups. And it's decided to pick things which are close to each other. So because it's ordered stuff by the sales column, and then resplit it in a more appropriate way, we can see that the ranges between the min and max of the files are very small. And obviously if the range between the min and max is small, more likelihood that you're going to have to look in less files. And in fact, we only have to open 1 file, because 14, falls between 14 and 16. So this is called Z-order and optimize, right? And this is just, if you hear Z-order, this is what Z-order is. It's ordering on a column to optimize, and then it optimizes by rejigging it. Okay, that is all the completely talking, nothing about Fabric or OneLake yet. I realize that we've done most of the time, but that is the underlying workings of it. And Delta Lake, you'll see, is a huge piece. So imagine, what is Microsoft Fabric? If you're not familiar with Fabric, think of a typical data project where we have a bunch of different data sources. We might run something like Data Factory and make a database, a data warehouse. Then we might say we have data scientists and they like this unstructured format. So we make a data lake, and this is where we do our machine learning. And of course, because we love Power BI, we do Power BI reporting off it. So there's a whole bunch of different services, so from a whole bunch of different sources. What Fabric has tried to do is says, look, this is getting really confusing because we have to piece everything together. So why don't we just put everything in one service and call it Fabric? And that's essentially what it is. They've said all of these that we commonly use, we're going to call this Fabric. The key part is that we're going to store everything in Delta format, and that is OneLake. So this OneLake is this Delta lake. So it's a data lake that uses Delta, and every service within Fabric uses OneLake. The only new thing is actually Data Activator, which just came out. This is a new tool. All of the rest existed before. Arguably OneLake didn't. It's the storage, it's not really a service. But all of these existed before. And what they're doing though, the big change, is they're all using OneLake, which is a Delta format. So it's stored as Delta. The big thing here is a single copy of the data. And that is what OneLake is. So imagine that we have a process, right? Similar process. This is the olden days before Fabric. What we actually normally might do is build data marts here, where we do copies, maybe some different types made for reporting. And then we're going to do this, and we actually have a copy in Power BI if we're using import mode. So everything here, this is a copy of the data, right, from our source system, because we've copied into Warehouse and a lake. We've then copied it into a data mart. We've then copied it into Power BI. What OneLake says is, well, everything is going to use Delta. Therefore, we don't need to copy the data. Every single service will look at the same copy of the data in Delta format. And what they did is they just went and they made their SQL databases. They made it work with Delta. Same with lakehouses and same with Power BI. So now everything just uses this Delta format. And now we have all our services and they all just use the same version of the data, right? And some can read to it only and some can write back. So let's have a look how Power BI fits into this. Quick refresher. If we're in direct query mode, when someone looks at a Power BI report, internally, when we publish a Power BI report, we always have two elements, and you'll see this when you publish it to the service. We'll have the report, and then what they call the data set, which they're now, I think, starting to name a semantic model. So in direct query mode, if a user looks at a report, it's actually going to query the database directly. So if you're not familiar with direct query mode, don't worry too much. But it says, it goes to our data set and it says, how do I use the data? What DAX measures do I use? But essentially you're querying the data directly. What we're really interested in is import mode. So import mode copies data from the data source into the Power BI data set. And then our reports, so a single report, multiple reports, use data from that data set. Now this orange here, so this signifies the data set. In import mode, we have two elements, right? We have the data itself, and then we also have the metadata. It's very important. This is internally, we can't see the differences, but in a data set or a semantic model, we have these two elements. We have the metadata, and in the new version of Power BI, you can actually see this. This is things like your code, your DAX queries, your Power Query, things like the relationships. That's all stored in a file called model.bim, and it's just a lot of code which says, this is how to sum things up. We also have the data, right? And that's the rows and columns. That's copied, imported, and also stored in the data set. So you have the data, and then you have the metadata, which is the information on how to use the data. So what is Direct Lake? Well, let's focus, back to Fabric, on the Power BI side of it. And let's look at Power BI just looking at a data set. Now, in a traditional data set, right, we have these two elements. We have the metadata and then the data itself. So the data would be copied in on a scheduled basis. The metadata will be changed if we write DAX, and this is all the code that we write. What Direct Lake does, and it's a new way that Power BI can use to store data and connect to data. So now you will have import mode, direct query, and this new mode called Direct Lake. Analysis services, which is the engine which powers Power BI. I mentioned earlier, this stores data in a columnar store format, the same format that Delta uses and Parquet uses. So what they said at Microsoft was, well, you know what? Why don't we do this? Split this out a bit. Now you don't see it split out, it's all internal, you can't see this, but underneath the covers, that data now isn't stored in the Power BI, it's stored in the OneLake. And now the model is just a bit like Direct Query, it's just the metadata, it's just your DAX and your code and your relationships. The data itself isn't now stored necessarily in Power BI, it's stored in OneLake, which is all the same service really. So a bit like import, what actually happens with Direct Lake is this. The data now is stored in OneLake. So OneLake is the storage, and the mode to connect is called Direct Lake. OneLake is the storage. So data is copied. You still have to obviously put your data into OneLake, but data is copied using Fabric tools. So I don't use Power BI tools. You can still use Power Query and all that, but it's done via Fabric. And now it works similarly to Direct Query, where my report gets the data from OneLake. The big difference here is that unlike Direct Query, it's still all in Microsoft world. So what this means is that it's very, very quick. It's still quick because Direct Query is terribly slow. In addition, unlike Direct Query, I can still write all those complex DAX statements because even though the data is in OneLake, it's still in Fabric and we're all in Fabric. So we're not having to query directly the source. And again, this is stored as Delta. So the cool thing about this is now you don't have to wait on Power BI refreshes. So however you're getting your data into OneLake, and it could be things like through SQL. So the big part of this is that we share this data set. So the data that is in OneLake is also the same data that the SQL servers use and your data lakehouses and your machine learning engineers use. So instead of having to have the extra process where I then copy the data into Power BI, it's all the same data set. So it's always a lot fresher. You'll get a lot more up to date. Now the biggest confusing thing is you can still refresh data in Power BI when you're using Direct Lake. But if we're saying that the data now no longer lives in Power BI, how can we refresh the data? Little differently, that just like in our process where we have our transaction log, instead of putting the copies in, if you do a refresh in Power BI using Direct Lake, it says, well, what's your current task? So it just loads this version of your Delta. Then if I have add a new file, right, my Power BI will actually just read up to task 2. So it will actually go back and it will actually be looking at this version. This is helpful. You do have the option just to always use the latest version and always be up to date. But you can do refresh because you might want to validate data before you start reporting on it. So that is Direct Lake. And that is data stored in OneLake as Delta. It can always be up to date, right? Because we're not doing that extra process of copying it in. And the idea, though, is we still have the same performance, even though we're not copying data in directly. I think sometimes, because I'm sure in time it will be equal, it's still not exactly the same, right? This is Microsoft's sale. They said your data can be always up to date because it's the same data that's used in your databases, and you can still use the same performance. But it can be up to date. There's still some things where they're still working and making improvements. So sometimes the performance isn't as good. And you can still refresh the data. Basically, this just takes the state of your Delta Lake, and that transaction log. So that is Fabric, right? So it's a Delta Lake, allows big unstructured data and ACID functionality. It uses OneLake, which is a single copy of the data. It's multiple teams and features can access, right? So data scientists, your SQL people. And Direct Lake, it uses this OneLake data store within that semantic model, right? But the logic lives in Power BI, but now the data lives in OneLake. Awesome. So that is, I think we've got a couple of minutes left. That is Fabric. And a very quick, again, please go to this site and you can review it or come back and watch this video again. I have a lot of these concepts if you missed stuff.
Excellent. Thank you very much, Steve. A great session, a great walkthrough there, an instructional session in terms of how data is stored from a Power BI perspective and how that translates into Microsoft Fabric and some of the new capabilities available there. So thank you very, very much for going through that for us in detail. We do have some questions which we've managed to save until the end. So I'll just go ahead and hand over to Pragati to ask us our first one, if that's okay.
Yeah. So the first question comes from Shivang Dalal. If you delete or modify any table through Parquet for the use in Power BI, does it change it across services connected to the OneLake?
So I think it's important to say direct query, right? Direct Lake is one method of connecting to the data. If you're using Direct Lake, for example, you'd still do everything through Fabric, but Fabric does have data flows in all your Power Query. You can still import into Power BI and still do that import if you wanted and do everything in Power Query. But if you're going to edit the underlying data set, you'll do that through Fabric, and then that does change it across all services connected to the OneLake. Right? That's the idea, that we don't copy it, but you still could if you wanted to do specific Power BI things.
Thanks, Steve. Leon, would you like to take the next one?
Yes, please. So this question comes in from Feras Al-Ramali. So please excuse the pronunciation of your name if I've got it incorrectly. The question is, if I have 1 million records, do I need to split Parquet files by myself? Or when I load the data to Delta table files, Delta table Parquet, will the files split?
Yeah, so everything's handled for you. Everything's handled for you within Delta. You can kind of change options, and there's a lot you can do when you're writing the code. But essentially, this is what Delta does, right? It knows this, and it does all this for you. It does this behind the scenes, and that is the power of it. You're not having to come up with this. You can do things like optimize and then try and tell it, hints like what to sort on. But yeah, it's Delta, and this is the beauty of Delta.
Excellent, thank you. And Pragati, I'll hand over to you for the next question, please.
Yeah. So the next one comes from Russell S. How does partitioning work in the new Delta Parquet format for optimizing queries?
That's a very technical question. I mean, you can pretty much partition by files. I think that's a bit too hard to go into detail. Essentially, you can partition, and it's going to more or less, have your files in partitions. There's a lot in optimization. This was a very high level concepts, and it's very abstract. There's a lot of code underneath, so might be a worth going. You can, and it's similar to kind of the Z order and optimizing things. A bit too much to go into in a couple of minutes.
Thanks.
No problem
Thanks,
at all. Thank you. Okay, moving into our next question. This one comes in from Ahmed. Ahmed asks, in Parquet, where is the metadata stored?
It's essentially everything stored, within the file. And again, think of Parquet as it's self-managed, and with Delta especially. So Delta obviously has that transaction log. With a columnar store, you will have things internally. You won't be able to see it necessarily. That says things like hierarchies and attributes that are built internally. And that's kind of, I think, the metadata you're talking about. It's all kind of there. You can't read it, for example. And it doesn't do exactly, it doesn't look, like I said, right? It's not going to have an index of 1, 2, 3. It's all computer nonsense that we wouldn't be able to understand anyway. So it's all kind of in that file. It's not like a metadata file that you can read.
Excellent, thank you. And Pragati, I'll hand over to you for the next question, please.
Yeah, I think Harry just asked, will this video stay up as a recording for watching again later? So yes, Harry, I think I can answer that. Yeah, so the recording of this session will be available on our YouTube channel, and we have shared the link of YouTube channel in the comments. So yeah, this will be available for you.
Excellent. And I'll let you ask the next question as well then, if that's okay, Pragati.
Yeah, that's fine. Which one I'm going for? We have got a few questions. Okay, let's go with this one. So yeah, the question comes from Ferris Al-Ramli. Sorry if I'm mispronouncing your name. Oh, this was already done, right? Did we just talked about it, right? Sorry.
We have. So let's go for this will be our last question as well due to timing. I'll let you choose it, Pragati. That's absolutely fine. There's a few to choose from.
I'll just choose this one because there was already a question from the other person. So yeah, this comes from Harry, and he's asking, a column store breaks the connection between the person and the transactional information. So how do you run a query for, say, Sarah purchases greater than 14?
Yeah, so the beauty of columnar store is that even though everything's stored as a column, because we've kind of added these extra bits of information, it's going to know how to unpack that. And so it will be able to extend fully. It will basically undo everything it's done, extend fully, and in memory, it's going to rebuild that row and column internally. So one thing you'll notice is everything, the rows have to be sorted in the same order. And if the rows are sorted, even if I said, build 3, and that's why you have where the rows start. So internally in the columnar store, it has all the information to rebuild that original table. And therefore, it will do that in memory. It sounds like a lot, but it's very, very quick and very powerful. And it's really optimized. They've been building this for years, right? So they got really good at making it run very fast.
Excellent. Thank you. Thank you very much, Steve. And like I said, absolutely great session. Very much. I think that the audience would have learned a lot today in terms of the underlying structures and how they can actually benefit from them in the future as well. So I'd like to thank you really for sharing your wisdom with us. We have put into all of the chats links directly to your website, and also that's been shown directly on the screen as well. So please do reach out to Steve if he can help you all at all. Excellent. Thank you. And with that being said, myself and Pragati would just like to thank you for joining us today at the Microsoft Fabric UK user group. We try to make these sessions very much an opportunity for you to come together with us as a community to learn more about the latest Microsoft technology.
And yeah, thank you everyone. And please don't forget to fill up the feedback form, because that's how we bring in the content that you're looking for on the user group. So please definitely go and fill the feedback form, and please, we'll be more than happy to see what you all think about the content that we like to bring for you. And the only last thing, please don't forget to register for Data Weekender, which is happening next Saturday. So yeah, it's a virtual event. So yeah, you don't have to come in person. You can just attend it from anywhere around the world. So thank you everyone for attending today.
Please don't forget free learning, free learning, free learning. Data Weekender, be there. See you all soon. Take care. Stay safe.
Thanks everyone. Bye.